All right, so in this problem, we have the square root of 3 to the power of x is equal to 81. Now, to solve this, I'm going to start here with the square root of 3. So let's just ignore everything else for a second and focus on the square root of 3. Now, the square root of a number is, say, the square root of x. This is the same thing as x to the power of 1/2. Because basically, the root here is 2, but we just don't write that. And the cube root of a number, that's that number to the power of 1/3, because we have a 3 over here. So the square root of 3, we can think of 3 as x in this case, and we can rewrite this as 3 to the power of 1/2. So now, if I substitute in 3 to the power of 1/2 for square root of 3, I get 3 to the power of 1/2 to the power of x is equal to 81. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 1/2 to the power of x, that's going to equal 3 to the power of 1/2 times x, which is simply 1/2 x. And this is equal to 81. Now, 81, that's the same thing as 3 to the power of 4. So now I have 3 to the power of 1/2 x is equal to 3 to the power of 4, and this means 1/2 x is equal to 4, and x is equal to 8. So 8 is my answer. Alright, so in this problem, I have 2 to the power of 20 minus 2 to the power of 19 is equal to 16 to the power of x. So I'm going to first start by rewriting 20 as 19 plus 1. So now I have 2 to the power of 19 plus 1 minus 2 to the power of 19 is equal to 16 to the power of x. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, I have 2 to the power of 19 plus 1, and this is going to equal 2 to the power of 19 times 2 to the power of 1. Now I have this minus 2 to the power of 19 is equal to 16 to the power of x. Now from here, if I factor out 2 to the power of 19 from my left-hand side, I get 2 to the power of 19 times 2 to the power of 1 minus 1 is equal to 16 to the power of x. And 2 to the power of 1 minus 1, that's simply equal to 1. And anything times 1 is itself. So I have 2 to the power of 19 is equal to 16 to the power of x. Now, 16, that's the same thing as 2 to the power of 4. So now I have 2 to the power of 19 is equal to 2 to the power of 4 to the power of x. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 4 to the power of x, that's going to equal 2 to the power of 4 times x, which is also 2 to the power of 4x. Now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, 19 is equal to 4x. Now we have a simple equation here. All I have to do is divide both sides by 4, and I get x is equal to 19 over 4. Now, to check, my original equation was 2 to the power of 20 minus 2 to the power of 19 is equal to 16 to the power of x. Now, 2 to the power of 20 minus 2 to the power of 19, we already know that's 2 to the power of 19. So we get 2 to the power of 19 is equal to 16 to the power of 19 over 4. Now 16, that's the same thing as 2 to the power of 4, so now I have 2 to the power of 4 to the power of 19 over 4, And these two 4's cancel out, so I get 2 to the power of 19 is equal to 2 to the power of 19. Alright, so in this problem, I have 3 to the power of x plus 3 to the power of x plus 3 to the power of x is equal to 333. So, the first thing I'm going to do is factor out 3 to the power of x from my left-hand side. So now I have 3 to the power of x times 1 plus 1 plus 1 is equal to 333. Now, I'm going to solve what's in my parentheses. So I have 1 plus 1 plus 1, that's equal to 3. So now I get 3 to the power of x times 3 is equal to 333. Now, we want to isolate 3 to the power of x here. And the way to do that is to get rid of this times 3. So I'm going to get rid of this times 3 by moving it to the right-hand side, and I'm going to do that by dividing both sides by 3. So now I get 3 to the power of x 3 to the power of x is equal to 111. Now, if I take the log on both sides, I get log 3 to the power of x is equal to log 111. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front. So it's going to equal b times log a. So in this case, I have log 3 to the power of x, and I can move x to the front. So I get x times log 3 is equal to log 111. Now if I divide both sides by log 3, these two cancel out, and I get x is equal to log 111 over log 3. Now, I can write my solution in two ways. The first of which is to actually divide log 111 by log 3. So log 111 divided by log 3, this is equal to 4.29. So this is one way I can write my solution. Now another way I can do this is if I have something in the form log a over log b, this is going to equal log base b of a. So this is another way of writing my solution. Alright, so in this video, I'm going to be solving the equation 8 to the power of x is equal to 88. So, my only variable in this equation is x, so that's what I'm going to be solving for. And now for my solution. I'm going to first start by rewriting my equation down here so I have a little more solving space. So my equation is 8 to the power of x is equal to 88. Now I'm first going to start by taking the log on both sides. So I get log of 8 to the power of x is equal to log of 88. Now, if I have something in the form log of a to the power of b, I can move this exponent b to the front, so it's going to equal b times log a. In this case, I have log a to the power of x, and I can move x to the front, so I get x times log 8 is equal to log 88. And the reason this property is so useful is because before, x was an exponent. And for our equation, if x is 1, I get 8. If x is 2, I get 64. And if x is 3, I get 64 times 8, which is 512. And we want to find what value of x results in 88, which is somewhere in between 2 and 3, but we don't know exactly where because it's going to be a decimal. So we can't really find the exact value as x when x is in exponent form. So this is why we can make it into a real term using this property, and now it's much simpler to solve for it. So now I have x times log 8 is equal to log 88, and I want to isolate x because that's what I'm solving for, so I'm going to get rid of this log 8 by dividing both sides by log 8. So now these two cancel out, and I get x is equal to log 88 over log 8. Now log 88, I can rewrite this as log of 8 times 11. So I have log of 8 times 11 over log 8. And now another property of logarithms is that if I have something in the form log of a times b, this is equal to log a plus log b. So log of 8 times 11 is going to equal log of 8 plus log of 11, and I have this over log of 8. Now, if I have something in the form a plus b over c, this is equal to a over c plus b over c, which is a simple fraction property. So log 8 plus log 11 over log 8, I can write that as log 8 over log 8 plus log 11 over log 8. Now, log 8 and log 8 cancel out to get 1. So I get 1 plus log 11 over log 8. So now all that's left is to plug in the actual values of log 11 and log 8 and solve. So log 11 is equal to approximately 1.04, and log 8 is equal to approximately 0.90. So I get x is equal to 1 plus 1.04 over 0.90, which is equal to 1 plus 1.16, meaning x is equal to 2.16. So this is my answer.